everyone, this is Michael. I wanted to walk you through a Rails TypeScript project I built for a maze game. Typical, try and get from your starting square to the finish here in the checkered square. In addition, there are some special cells like these blocks down here in the keys that add some additional rules. So the basic setup is any of these colored blocks you cannot pass through until your character has gone through the corresponding key color. So you'll notice I can't go to the right here at all until I've gone up here and traveled to this key over here. Changes my cursor to match, showing that I can now move through these squares. Same goes for each color. You have to go through the corresponding key first. And the last special cell I have are these ice cells, where as soon as you pass through one, you will kind of slip and continue going in that same direction until something blocks you. So going down gets me back to the bottom. To get through here, I have to go to the center and then go through. Alright, so let's reset the level. So in addition to this, I have built-in pathfinding algorithms. Let's run through this and see what happens. So what you'll notice for traditional breadth first search, what it does is every time you pass through a node, it keeps track of that and says, okay, if I get a new path to go to that same node, discount it. I've already gone to this in a shorter path, therefore it's not possible that this new way of getting there is part of our solution. The difference here is that each key you pass through causes a state change for your puzzle. So you can't do that setup anymore. If I move, we're going to reset the puzzle. If I move down to here without going to the key first, you'll notice there's no way to finish the puzzle. And if I used that previous logic, the algorithm would just end. Because other paths, say I go down here first, which is what you have to do to solve this, getting back to here would end the algorithm. So what we do is instead, for every node and every combination of keys unlocked, that's what we save to determine whether or not we've been there already. And that you'll see represented in the colors on the squares pop up in our pathfinding algorithm. So you see, we run it again. Starts out red, and then once we've passed this key, you'll see we're getting this light blue color, and then you'll see a bunch of colors based on the combination of keys unlocked down here. And you'll notice how slow it kind of moves towards this point. That's because there's like 8 or so different paths that it's considering. So that's where we get into these extra, more advanced algorithms like the A-star search. A-star search prioritizes paths closer to the finish beforehand. So when we run this as A-star search, you'll notice once it gets to here, it kind of goes straight to the end. It's not considering these paths that go down first, and it will look at them. Eventually, it's just going to prioritize the paths that are closer first. So that's the basic setup. In addition to that, I have a level editor where you can build your own puzzles, put in a finish, put in a start. You can run through them yourself if you want. You can also run the pathfinding algorithms if you want. And this gives kind of a cool combination of a couple different things. One being the traditional pathfinding algorithm application, where you have a user build the path it wants to look for and test different algorithms, and the other is an actual like web game that you could push and say solve each level, get your character to the end. I think is a nice combination of applications. Thank you for watching, and goodbye.